Yeah, thank you. So what I'm going to try to do, I've tried the PC. I think it is a problem with my device. I am going to share this presentation, or preferably I can share the PowerPoint, and then I'll give you a link to where the PowerPoint was obtained from. In fact, it is B.Bat Gastman. That's where the presentation is from. And as I try to, if by chance it connects, well and good. Can anybody just try again and forward me this link on my email so that I don't tamper with this one? Just send it on my email, that link. I will appreciate. As I share with you the same presentation. Sending the presentation on Joshua's email. I can send it to Joshua, then he can share with you. Yeah, so as I try to log in and send, maybe I'll just give you a hint on what the presentation is about. I really felt I'm not teaching the whole of the slides, but I just thought we'd go through the basics, the foundation of hypothesis testing. It is something that many people just memorize. They memorize. For me, when I'm going to get sample size, this is what I get. Hypothesis testing, this I just read and that's all. But sometimes good to understand the underlying principles, because when you understand that, if maybe someone changes, say we're changing the sample, we are changing this to this, it's much easier for us to adjust to his approach than when we had crammed a certain technique. That's why I'm going to spend some time to basically explain the examples that are there on the presentation, but we may not look at those examples. I'm going to look at the few things that are in that example. And at your free time, you try other examples. That's the intention of me trying to present this. Just give it a try. Has anybody sent me a link on Gmail?
Yeah, I've sent it to the master account.
Okay.
I've sent it through the master mail.
I'm trying to. Seems it has not yet. Looks like my network is bad. But as I wait, let's go through the presentation. I'm sharing with you later shortly. So, sorry about that. So it is the basics of hypothesis testing, and through the presentation, it highlights what is involved in hypothesis testing. The first thing is appreciating what a null hypothesis is and alternative hypothesis is. This arises because realistically, someone here is making an allegation about something. Is making an allegation that something has happened or something is true. So that allegation is what we are referring to as a hypothesis. When you carry out a research, you are going to write a paper or you are going to write a report about something and you conclude this is true, this one applies here and is best fitting for these type of patients. Those are allegations. Not until you confirm whether it is true or false. So those allegations, what we call hypothesis. Now, that specifically, it is the null hypothesis. Now, if your allegation is not true, then it is taking the position of an alternative. So when we're working with the hypothesis testing, we are testing whether your allegation is true or false. When it is true, then we say the null hypothesis is there's reason to trust it. If it's not true, then we say the alternative is right. So that is the principle where everything starts from. Yeah, you can just try. Yes, I'll go to the link here. Yeah, as it was. So we're going to define what that is. Then for you to find out whether that hypothesis is true or not, you need a statistic. You need a number. Then you base on that statistics to determine whether someone's allegation is true or false. So we compute that statistics. Then after computing that statistic, someone could conclude from around that point. But normally, for that person who's not very, very comfortable, you will go ahead and compute what people normally quickly come to, the p-value. The p-value is this. Then we are concluding, but what is the p? Why do you say because the p-value is small or big, I'm making this conclusion? Why do we say that? It's because we appreciate the data that we've been working with. We appreciate its distribution. And if the distribution follows a certain format, then we know where someone comes up and says, yes, the hypothesis, there's enough evidence to show that it is true, or we don't have enough reason to believe it. In the process of doing that, someone will say it is true only to some degree. They say maybe in a whole class, our would say our age, say your age is around some range. Someone will say, no, our age, we are between 10 and 20, 20 and 30, 30 and 40. So if someone tells you, try to prove whether this is true, you will get an average value. Then you will conclude and say, no, the average age of this class, just look at this. Someone says the average age of this class is under 10. You see, it's between 0 and 10. Someone said that is very wrong. Why? Because he expects some age limit bracket. For someone to be at campus, this should be the range. You see, that is the level of significance coming in, level of trust on that data. If someone tells you the data received and the age, average age is 5, you throw it off because you know the level of trust you are going to give the age is based on some range. Say now, another one will come and say the age bracket is between 25 and 35. Someone will accept that a bit. Say, at least there I will agree with you. Because there's a level of trust that you expect. So that's where we define what we call the significance level. Let me test my connection again. Just a second. Okay. Right. So then we are moving. I'm just giving you an overview of what the presentation is. We have not got the details yet. Then when you're testing, someone could say in maybe in a certain hospital, Barra Referral Hospital, they say if a victim or a victim of an epidemic is brought to the hospital within the first week of infection, there's a certain percentage chance that he is going to survive. Yeah, maybe out of experiment, out of experience, you realize that normally those people they are brought within the first week. They will not spend in the hospital more than 3 days. You see, I'm specifying more than 3 days. So that is an allegation we have to prove. Someone will come and say, you prove what you're saying. Then we'll bring reports, data to prove that. But you see, I am saying this person will not spend more than 3 days in hospital. on average, he's not going to spend more than 3 days. So what is the alternative there? If he's not spending more than 3 days, then what time is he going to spend? He's going to spend less than 3 days and less. So what are you going to test? You are going to test whether the other alternative is true. If it is true, then this guy's allegation is wrong. If the other alternative is wrong, then his allegation is right. I've proven him right or wrong by looking at the other alternative. So our alternative here, many people, many students, they feel a null hypothesis, we have defined it, then the alternative hypothesis is the opposite. That is wrong. The alternative is not necessarily the opposite of the null. It is anything that is not null. We shall realize that sometimes it's beyond just having the opposite, we're going to see. Now, when we are working with hypothesis testing, there are some provisions that are there to simplify our work, to simplify our computation. That brings in what we call power. The power, we compute power. So instead of just basing on p-value and concluding someone can compute the power, now this one gets a bit beyond the scope of our work, but it's just good to appreciate what it is. Because if you have a formula, you just feed in the values and come up with your conclusion. So that's the rough idea of what the presentation is about. I hope it is going to open this. Let me try again. All right, as it is signs on slowly. I'm reminding ourselves with about what you covered earlier. Just a few concepts which are used in hypothesis testing. We all know that a population are all possible values. That's a population, all possible values. Then a sample is a portion of a population. I think we remember that. Then when we're making an inference, we're making a conclusion about, take note here, it's not about the sample. We're making a conclusion about the population. So hypothesis testing, to a good extent, is for a population basing on a statistic. It's not for a statistic, a sample. So that two different ways in which we can carry out that inference or make a conclusion about a population. It is estimation, it is hypothesis testing. So ours here is hypothesis testing. Estimation is what you covered, that read material I gave you. You just compute mean estimate for a population basing on what is on the sample. I get a sample of 50 people, compute the average weight, and I make a conclusion that the population's average weight was this. Of course, as you do that, the errors you're making. And the same applies to hypothesis testing. As we do it, the errors that we're going to make. So what are these errors? I guess when you're ready, you identify those errors. But how are those errors obtained? How do we conclude? Why do we start saying it's an error? Going to see that. Yeah, I think I'm now on. Just put my hand off. Yeah, so can you confirm? You can see it.
Yeah, yes, I can see.
See
also not getting your voice inside.
Yes.
Yes.
Is my
Is my
are we okay there?
Are we okay there? Yes, I can get you now. I'll get you now.
Okay. Try to mute.
Okay. Mute.
All right. I'm just worried about the echo.
Just worried about the echo.
So I was explaining that point. Wow. Guys, this is sound still that bad. Hello, do you hear me on that one?
Yes, 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 I can get you. Yeah.
With an echo.
Okay. I'm disconnecting one. Confirm again. Are we there? Okay, okay. Hello? Guys, it's okay there? All right, sorry, I realized the problem. So, sorry about that. So, I was just explaining. That I'm having just a general problem with the voice disappears. Please just remind me. I've also lost the voice a bit. So notation, we are clear with it. My point where I wanted to highlight is we mentioned that for a population, the parameters, it says it may vary for a population. That's for parameters. Whereas for statistics, it may not vary, sorry. For a statistics, it's going to vary. Why? It's because out of a big population, you can generate many samples. Out of Uganda, you can generate a sample, maybe the north to represent Uganda, the south or the west. So if you carry out those computations, you expect the means to vary. That's what we mentioned earlier. As for the calculations, obvious, that is what we highlighted, that from a population, you generate a sample. Sample, you have data, sample data, you compute a statistic about a population. None mentioned that. Now, our issue is at this point here, I wanted you to confirm whether voice is okay before I start it. Yeah. Well, on this slide. Seems we are not on. Let me share. I'm going to share that information here. There, let me send something. Okay. Looks like try. Sorry about that. There is going to be an echo, but I am going to let you. I turn off that. Turn off that. Just download that. Just download files. Just download files. Okay, I've shared with you a copy, that PowerPoint. So I'm going to explain, use it as you move from slide to another, I think. So that we avoid that disturbance. So I was on that slide, just remind you, that is slide number 6, sampling distribution of mean. So I'm requesting to confirm whether it's clear, please, before we proceed.
Yes, it's clear.
Okay, sorry about that disruption. So on slide number 6, what you should be seeing is sampling distribution of the mean. A sample from West Uganda could represent Uganda. Get Central still represents Uganda. Could get the North. Now each of those is, we could say, a part of the sampling frame. Each of them you can use it as a sample, but they will not give a representation. Whether you are using Central, they have limitations. If you use West, there are limitations. So any of these samples we are going to choose will not be perfect. So we expect errors there, not sampling errors. We're going to have them there. So if we get all those samples and generate mean for all of them, then you compute the mean for the different samples, you are going to get a distribution like what you see on your slide. That is what they call a normal distribution. So the mean will normally follow that normal distribution. When you see the formula, the first formula you have there, that's a mean. It's a sample mean. They say that sample mean follows, that symbol, follows n. N is a normal distribution. Any normal distribution is defined by the mean, population mean, and the standard deviation, standard error. So they put as n, open bracket, population mean, and standard error. That is how you represent a normal distribution. They could give you figures in each of those areas. How you compute the SE is down there. It is One will say, can we derive it from first principles? Yes, we can do it. Time will not allow us, but it's possible to do it. So we have the standard error. I mean, that one there is standard deviation over the root of sample size. It is sample size, not population size. So that is how we compute the SE, and that is the normal distribution. That's to give us an overview. I request you to go to slide number 7. In slide number 7 now, it wants us to link up this with that hypothesis testing. Yeah. That hypothesis testing is sometimes people call it significance testing. It's almost the same thing. So we want to test the claim about what is in the population. That's what I put in red there as the parameter. We want to confirm that. The technique we use, I want you to imagine this scenario. You have you have a population, and then you are testing. You're saying it seems the sample size, the average. Someone's unmuted, please. I request you mute. Yeah. So I would say you have a population or a sample, and then you make a conclusion that the average weight is 30. That is a hypothesis. That's an allegation I am making. So if it is not true, what do you think is true? What is the alternative? The alternative is it is not what you have calculated. It's not 50 that you have calculated. It could be less than, or it could be greater than. You see those two possibilities. It's not 50. So the other possibilities is either less or it is greater. So in that case, we're looking at two sides of the 50, of the mean. That's where they say a two-sided test. Yeah. If it's not a two-sided test, then it is a one-sided test. So one-sided, this is in a situation where they say, from our analysis of all patients who are admitted, all of them, their weights had deteriorated to less than 30 kilograms. Within 1 week, they lost weight. Everybody was less than maybe 30 kilograms. You see, the allegation is taking the whole one side. So someone says, what is the alternative hypothesis there then? You know, the alternative is what is not null. So if the null is less than, say, 50, so what is not null is greater than 50, equal or greater than 50. That's one side. So you're looking at one side. That's what they call a one-sided test. These are important because when you are making conclusions about your findings, that knowledge helps. Which knowledge we shall see. I'll be fast there. So what are the main steps, having got that background, what are the main steps you follow in hypothesis testing? Step number 1, by the way, they even ask, is tested, not just whenever you're being tested, maybe it is, they call it what, this brief test you go during interviews. I've forgotten it. So normally you'll start by identifying the null hypothesis and the alternative. Normally, as soon as you do that, you're done. All the other things are straightforward. Anyway, it depends on how you look at it. So you do that. Number 2, you'll get a test statistic. Now that test statistic, there's a standard formula, which is what we have mentioned earlier. I don't want to go, but we're going to see it. Then after computing that test statistics, it's basically you to compare, because you'll compute that test statistics, then go and read some value on a statistical table. And that is the main thing in hypothesis testing. If we identify those 3, and then the 4th, of course. Oh, someone's telling me there's a power problem, but I still get 8 people. Sorry. I think let's just proceed. Sorry about those who have power problem. So then you get the significance level. Sometimes, as we were illustrating at the beginning, they give you data. Then we have specifically they say we want you to do a test at this level of confidence, that significance level of confidence. That's where that option comes in. So it's optional in a sense that someone may not ask, may ask, but it's good to appreciate what it is. So in your reading, try to be comfortable with all those 4 areas. If you do 2 numbers, you'll internalize it well. 2 examples, do it. So those are the 4 steps. What do? Convert, null hypothesis, alternative, which we have illustrated. I will move fast a bit here. I highlighted that. That's what I wanted to show, that a null hypothesis is not always the opposite. Alternative hypothesis is like you take somebody to court. Null hypothesis, someone alleges takes you to court. So when your defendants come in, they will try to look at the other possibility. Say you brought our people to case here, but this thing was like this. When you prove the other one right, it was another person who did it. You're set free. So likewise, when you're doing hypothesis testing, someone is claiming it is 50. So what hypothesis testing does is to come and try to show that alternative is true, that null is not right. That's the computation. That's the reasoning behind hypothesis testing. An allegation is made. You try to come and show that the alternative is right. So your allegation is not right. So it's more of, I could call it a fight. You just come to prove somebody wrong. That's what it is. So you collect data and seek evidence that H naught is not what they're claiming to be. I talked about the null, one-sided and two-sided, and these are still the same examples here. So he gives that the problem is that, I will not go through it here, but it brings us to the null hypothesis that the mean is 170. As soon as this guy says 170, you know what is the alternative? It's not 170. So say the less or greater. That's why this one becomes a two-sided test. H alternative will be the second one. If it was a one-sided test, then someone would test whether it is greater than. Maybe someone has claimed it is less than. The other one says greater than. Yeah, my power was also going off to connect something very fast. Okay. So there we have examples that you will compute. That's the formula. That's the statistic, test statistic. Here, I will just mention that when you're doing your statistical analysis, it is not always Z. Your sample size determines your test statistic. So if you are going to do your research and you say, we carried out statistics, this is my sample size, and this is the Z, it's enough for someone to say, you are either copying and pasting or not. Why? Because different sample sizes will determine whether you're using a Z or a T. So confirm whether your sample size qualifies you to use a Z or to use a T or something else. Otherwise, the formula, you just feed it like that. Now, the other thing I would like to mention there is, it seems someone's moving it, which is good. Thanks for sharing. Thanks a lot. So, normally, the data you are collecting is kilograms. Someone's 80 kilograms. Another one's 100 kilograms. Another one is so and so. So, those numbers, you're not going to read it in a statistical table. A statistical table reads standard values. So your data that you're collecting has to be converted into a standard value. In other words, you standardize it. By standardizing, you're basically getting the Z value or the Z start. If there's
Recording in progress.
Let me try to give someone the privilege. Peace, I'm going to make you the host. I hope you will allow. Anybody, you can try to share. If it comes, it comes. If it fails, let's proceed to get our time. If anybody can share the screen, just feel free to share. Thank you. Thank you. You can put on slide view. On slide number 13. Yeah. So I was saying this is just a computation. Now, if you go backwards to the previous slide, we had the formula, then we computed the state statistic on slide number 12, where of course we are given mu is 170, standard deviation is 40. The standard error came to 5. So if the mean, for example, is 173 that we're given there, then the Z value is 0.6. If you go to slide number 13, there the mean is 185. The Z value is 3. That is true. So when we go to slide number 14, it is telling us we can compute that for all the samples, sample 1, sample 2, sample 3, all those values. And if we do that and draw a graph, we shall get that type of distribution, that normal distribution, which is represented by our formula down there. Mean takes on n in bracket 170 dash 5. That's how we present it. So it's just trying to show us that we're dealing with many samples from one population. But the values we're going to get will affect our decisions that we see later. Yeah. Slide number 15 now. 15. Yes, we're there. 15. So that just shows what I'd mentioned, that we have to convert our alternative hypothesis either to a one-sided test or to a two-sided test. You just, there's some animation there, you have to click. Yes, that is it. So then we go to the table and read. I guess we are comfortable reading the Z value. If you go to slide number 16, assuming it is 173. So in up there's where you see two-sided arrow with a 5. That is the standard error. Standard, we could call it deviation from the mean. How far are we away from the mean? Now, if that gap is very wide, that shape is going to change. It will become very low, and then our normal distribution will cease to be a normal distribution. It will just be an estimate of a normal distribution. So normally, we want that shape to be maintained. So what is the probability we are talking about? The probability, the p-value, is that area after 173. 173 is what we have calculated from the Z. So our alternative is that area. Again, I would just like to highlight this is another area that can mix you up. You can read, follow it up to that point, and the table messes you up. Now, those tables are different. Those tables, when you read the tables, they have this shape. Somewhere, either top right corner or below, that's showing you that table is giving you the Z value as the area that is shaded. So assuming they shaded it like that, so they're telling you the value is that area to the right. So if someone tells you we are looking at the probability, the value is less than 173, then the Z value is not going to represent what you want, because it's saying the value has to be less than 173. So you have to compute it. You know the total area under that curve is 1. That's total probability is a 1. So if your attention is for area to the left, I mean the unshaded, you may have to do 1 minus area of the shaded. So you have the p-value 0.27. So your probability is 1 minus 0.2743. Okay, I'm using this picture to explain many things. I hope it doesn't mix you up. However, at that point here, that was the value for 0.6. That's the shaded area. And then the p-value, that's the p-value that is shaded. The z-value is a 0.6. Okay, why is the p-value is important? That p-value, when you compute it, will help you ignore or say that the null hypothesis that these guys are alleging cannot be dependent on, or there's no reason to believe in it. Why? If that is p-value 1, then it is significant. If it is big, then the null hypothesis is, let me use the word fake. Okay. So our point, be comfortable at the area that is shaded there. Please, maybe if there are other issues come later, you feel free to contact. I know the course ends today, but you can inquire later on. This is for 185. Now 185, you're not seeing the shaded area, but it's very small. So you see that what is being highlighted for this example is that the fraction there is very small. So if it is very small, do we say we support the null hypothesis or we reject it? It is not the obvious. Okay. Let me move to the next. Two-sided. Now we're doing a two-sided and you're computing the p-value. You'll get p-value on one side and just multiply by 2. Reasons, this image, this sketch is symmetric to the center. Symmetric at the center. So if you're looking at two-sided, you're doing what is on the left, seeing what's on the left and what's on the right. So even when you're making conclusions, multiply by 2. If it is beyond, say, 0.2, you know that is a big significant because that value is big. So you make a conclusion after multiplying the 2, multiplying by 2. Because if you make a mistake, it is a two-sided, and the only look at would be an error, not give you the right mark. That's the interpretation that we're having there. That small value, strong evidence. That null hypothesis, you have to look at it carefully. Let's read here. Small and smaller p-values provide stronger and stronger evidence to reject the null hypothesis. That's what is highlighted there. By the way, on slide number 19. Sorry, I didn't mention. Yes, that's where we are. Just giving us how to interpret that. There's one thing I'm hurrying to, which I want to conclude with. The others are just obvious. You're reading on the table, you're reading p-value. There's what is called power. Power, we shall not look at it. May not be necessary for now. But I wanted to explain the error. These are just two examples of one-sided, two-sided. I want to move fast to the error here and explain. This is just a worked example. So I want to spend time and explain something here. When you are looking at, when you get a sample and you use it to represent a population, we say there are errors in doing that, using estimation method. The same applies to hypothesis. So what are the errors in a hypothesis? This table summarizes it. 1, a null hypothesis can be true or false. Okay? It is either true that H naught, please let's move to slide number 28. 28. Sorry, I delayed you, delayed behind. There are the ones we are skipping. There's an example for a one-tailed test and a two-sided test. So we are on slide 28. You moved so fast ahead. Let's go back. Just click back to go to the previous slide. Where it's 9.6, power and sample size. That is power which we're not looking at. Go back, continue back. Back. Yep, we're there. So most of them build on this, even understanding power if you go and read further. So they all rely on that table. This table has our null hypothesis, H naught, is the truth value up there. We have H naught, which is the null hypothesis. true and then false. Then the decisions were either retaining or we are rejecting. So we reject null hypothesis or retain it. One would say, I thought you'd say retain null hypothesis or retain alternative hypothesis. Yeah, here it is more of emphasis on null hypothesis. They're assuming the values we have are for the null hypothesis. Otherwise, someone may reason alternative here, which we don't want at this point. So someone makes a null hypothesis, we can accept or refuse based on our calculations. So if you look at that first quarter, correct retention, there, and from our computation, you have gotten evidence that yes, it's true. So it means you're retaining it. If you retain what is true, is that a problem? It's not. Come down, just below correct retention. That null hypothesis might be true, and because of your errors with your computation, you reject it. That's where the error comes in. That's called error type number 1 or type 1 error. Type 1 error is the null hypothesis is true, you are rejecting. That's what arises. Now we are defining this because this is the basis for power and P that we'll see later. There you put the alpha and beta. Now we go to the false. There's a null hypothesis. It is false, but you have retained it. That is the quarter, that section there. Someone has got. It is not the slide we are on, by the way. What is my side, which is not seen? We are still there, yeah. You see type 2 error. There, the null hypothesis is false, but for us, we have decided to retain it. Possibly, it could also be error in computation. So if it is false and you retain it, then you've made a blunder. That's another error. That's a type 2 error. It is wrong, you are accepting. Type 1, it is true, you're rejecting. So those sections, those quadrants, make the errors type 1 and type 2. There are statistical methods that have been used to make use of those errors or to compute those errors. The other sections are true because it is correct retention or correct rejection. We understand. Because under false, other type 2 error, it is false and we have rejected it. No more, that's the right thing to do. So what we're calling our type 1 error is what is being defined as alpha. Mathematically, it can be computed because you have a formula for normal distribution, including standard deviation and so on. These are things you will easily get from publications. You can compute alpha, or you can use alpha if you're given. Or our beta is a type 2 error. You can compute a type 2 error and you can make use of it. And that's where our next slide starts. But at least I wanted us to have an understanding of, especially this one, this slide here. If it is not very clear, please revisit it. If it refuses completely, more material can share it. Otherwise, the other section is power, which I said I don't want to look at it now. But if you want it for reading, there's slides there on. So for today, sorry, I have to stop there. Sorry about the late start. I hope this can be helpful in your research and statistics later on. Now, regarding your assignments, I was just inquiring, are you people enrolled on LMS? Are you on LMS? Anybody respond?
No.
Doctor, maybe you tell us what LMS is because we may not be understanding. Thank you.
No, it's a platform. It's a platform where you could submit and get more material to share, but it's a process to get it. It's possible, but it will disturb us a bit. So you can just use the mail and send the coursework. Preferably, I would suggest before Friday. Max early, I would suggest before Friday. Then
Some of us had already sent your email.
Yes, if you have sent, good enough. If you have not sent, please let's do it early. Then number 2, I was requested to get your payment slips. That before I send the marks. So if I can get it through the class representative, I can either get it from Joshua, from Anthony. Be helpful. All right, so that is it for the module, I think. If you any comments, any suggestion, we stop today.
Yes, Doctor, thank you for your time. I think we'll be reaching out more to understand what we haven't in real time.
Yeah, sure. That's fine. All right, have a good day.
A good day. Thank you.